Hello, today's lesson is on domain and range with a greater focus on just domain, and then the idea also leading into piecewise functions. All right, so what is domain and range? If you're dealing with just a set of points or a function, domain would be your set of all of your x values, which means range is the set of the y values. So probably back in, I don't know, pre-algebra, algebra 1, maybe you just had a table. So this table doesn't imply that there's a continuous function going on at all. So if I'm going to list the domain, it's just listing the x values separately. So -13, -3.5, 0.7, and 4.2. And the range would just be listing the y values. And usually you list them smallest to largest. So -2.9, 4.2, 5, and 12.1. If I look at the graph, this graph of the square root function, let's see, as you can see, so it's starting at this point and x values. So it's continuous, it goes on and on forever to the right of the x value 1. So we could write the domain two ways. I could write x values that are greater than or equal to 1. So it includes that 1, or interval notation, which would be including the point 1 and going to positive infinity. All right, so then the range, let's look at the y values. So starting at that point, and even though it's not increasing very quickly, it's going to keep going and going forever and ever and ever up. So all y values that are greater than or equal to this y value 2, or interval notation, including 2 and going to infinity. All right, so last thing, looking at specifically focusing on domain for this last one. So what are possible x values that work? Well, we have this fraction, and all I know is, let's see, I can't divide by 0. So for example, like 2 divided by 0, can't do that. So that means denominator, this denominator x squared minus 2x plus 1 can't equal 0. So the denominator cannot equal 0. That means there's a restriction on the domain. So let's think about this. I have a quadratic that cannot be equal to 0. So what values of x are not going to work? So just think about solving this quadratic by factoring. So if we factor it, we will get x minus 1 times x minus 1. That can't equal 0. So the value of x, an x value, cannot equal 1. But you can have all other x values. So two ways to write this. I could say it's all real numbers except x can't equal 1. Or if I'm doing interval notation, I could say, well, from negative infinity to 1, and then also from 1 to positive infinity. If we were to graph this function, it's going to look like this, just kind of a quick sketch. So the y values, there's an asymptote, but it keeps going up and up and up. But we're not worrying about the range for the ones that we're looking at algebraically. We're just looking at, are there restrictions on the domain? Okay, the next part of this video is on piecewise defined functions. So a piecewise function is simply a function that uses two or more equations for different intervals of the domain. Okay, a function that uses two or more equations for different intervals of the domain. So as you can see here, here's a general graph of what a piecewise function looks like. It's like part of a function and then part of another function and then part of another function all pieced together. And here's what a set of equations might look like. You might want to pause the video and kind of write these equations down. But the idea is that this function, f of x, it equals, let's see, okay, so x squared minus 5x, but only on this interval of the domain for x values less than or equal to negative 10. And then it also is equal to this function, x plus 19, on this interval of the domain from negative 10 to negative 2. And then lastly, we've got this function, but it's only on the interval for x is greater than or equal to negative 2. So all we're doing right now for the piecewise functions is function notation. So we're going to find f of negative 12. So negative 12, we just plug in for x, but which part of the function do we use? So you have to look at your intervals. Negative 12 falls under which interval? Falls under the first one, less than negative 10. So we're going to plug in negative 12 into just the top function. So I've got negative 12 squared minus 5 times negative 12. And that should equal positive 204. All right, we're going to do two more of these. So now let's look at f of negative 3. Okay, so which interval does negative 3 fall on? All right, this middle one. So we're going to plug negative 3 just into the middle equation. So negative 3 plus 19 equals 16. And then the last one, let's find f of negative 2. So where is negative 2? Well, here's a negative 2 and here's a negative 2. But this one is only values less than negative 2, where this one is greater than or equal to negative 2. So I have to use the third one for negative 2. So I've got negative 2 to the third power over negative 2 plus 9, which equals negative 8/7. Okay, we're going to do same thing, but just looking at the graph. Function notation, but just on the graph, it's actually a little bit easier, I think. So f of negative 2. So just find negative 2. And then notice how I have a closed circle here, open circle here. So that means it's not including the open circle, but it is including the closed circle. So negative 2, we're just going to estimate. We're going to say that's about 1. Okay, let's look at f of 3. So 2, 3. The x or the y value would be at 0. 3, 0. And then last one, f of 4. 2, 4. I've got open circle there, so that's not it, but closed circle down here, which is about negative 7. So piecewise functions can look a little intimidating and scary, but if we're just doing function notation, it's just a matter of find your interval to figure out which part of the function to use. Okay, now we have just a story problem using piecewise functions. Before we read it, why don't you pause the video and write these equations down. All right, so let's read. We've got the average maximum height of children in inches as a function of their parents' maximum heights in inches can be modeled by the following piecewise function. Find the average maximum heights of children whose parents have given them maximum heights. So use h of x, where x is the independent variable representing the parent's height. So if we're looking at the interval, that's your parent's height that we'll be plugging in for x to then find the children's height. So the two that we're going to find is we're going to find the height of the children when the parent's height is 67 inches and the height of child of a parent that is 72 inches. So this is just obviously making predictions, looking at past examples and estimations and stuff. So if a parent is 67 inches, find the interval. Okay, that's the middle one. So plug in 67 into the middle one. So 3 times 67 minus 132. So if a parent is 67 inches, there's a prediction that the child will be 69 inches. And then the next one, if a parent is 72, okay, that's the last interval. So we're plugging it into the last equation. So 2 times 72 minus 66 is 78. So prediction is if a parent is 72 inches, they'll predict that the child will be 78 inches. Okay, there is your full lesson looking at domain and piecewise functions. Good luck with your lesson.